All right, let's talk about one of the most important and maybe one of the most overlooked parts of your computer. We're going to pull back the curtain on the DMA controller. It's the secret hero inside your machine that keeps everything moving when the main brain is just swamped. So, to really get why this thing is so important, let me ask you a question. Have you ever been, say, downloading a huge file and suddenly everything else on your computer just slows to a crawl? Well, that's often because the main brain, the CPU, is getting totally bogged down with busy work. Just think about your CPU like it's a super-powered CEO. Its job is to make the big, complex decisions. But what would happen if that CEO had to stop what they were doing to personally sign for every package, file every memo, and answer every single phone call? The whole company would grind to a halt, right? That's exactly what happens when a CPU has to manage every little piece of data moving around. And that is the exact problem that Direct Memory Access, or DMA, was built to solve. It's basically a feature that creates a high-speed data express lane inside your computer. It lets things like your hard drive or your network card talk directly to your computer's main memory, completely going around the busy CPU. It's the perfect fix for our overworked CEO. So how does this magic happen? Well, our company just hired a hyper-efficient assistant. And in your computer, that assistant is called the DMA controller. It's a special little piece of hardware that's designed to do just one thing and do it really, really well. Manage all that boring data transfer stuff so the CPU can get back to its real job. And its whole mission statement is right here. It's all about transferring data with, and this is the key part, very less interaction with the processor. It's all about delegation, plain and simple. But of course, this assistant can't just go rogue. It needs directions, right? The CEO doesn't do the whole job, but it does hand over a very clear, very simple to-do list before stepping away. And you know what? That to-do list is actually incredibly simple. The CPU just gives the DMA controller three little pieces of information. First, the address register. Where is this data going? Second, the word count register. How much data are we moving? And third, the control register. Are we reading this data or writing it? That's it. With just those three instructions, the DMA is good to go. And this process shows you just how clean that handoff is. The CPU quickly fills out that to-do list. Then the DMA controller basically says, okay, I got this. I just need control of the main data highway, the system bus. The CPU says, you got it, it's all yours, and goes off to do something more important. Then the DMA handles the entire transfer, all by itself, and only pings the CPU when the job is totally done. Now, once that handoff is done, the assistant still needs a plan. Not all data transfer jobs are created equal. Moving one giant file is a totally different beast than handling a constant stream of audio data, right? So a really good DMA controller needs to have a few different strategies, or modes, to handle these different jobs. And this table breaks down the three main game plans. First up is burst mode. This is the get-it-done-now approach. The DMA grabs the bus and doesn't let go until every last bit of data is moved. It's super fast, but the CPU has to wait. Then you have transparent mode, which is kind of the polite one. It only moves data when it notices the CPU isn't using the bus anyway. So zero impact on the CPU, but it can be kind of slow. And finally, there's cycle stealing mode, a really clever compromise. The DMA transfers one little piece of data, gives the bus back, takes it again, gives it back, and so on. And this really gets to the heart of the trade-off, especially between the two most popular modes. Burst mode is all about pure, raw speed. Just get that huge file moved as fast as humanly possible, even if the CPU has to take a little break. Cycle stealing, on the other hand, is all about working together. It keeps things moving smoothly for real-time stuff like audio, letting the CPU and the DMA kind of work in parallel, even if it slows them both down just a tiny bit. Okay, so we've seen how this assistant works, we've seen its strategies, but the big question is it actually worth it? Does hiring this dedicated controller really pay off in the end? Let's take a look at the performance review, the real pros and cons. Well, the upsides are huge. First and foremost, memory operations get a massive speed boost. And by taking all that data shuffling off the CPU's plate, its workload just plummets. This lets it focus on what it's actually good at. It's just a much, much more effective way to spread the work around inside the system. And wow, this chart just says it all. Take a look at the CPU's workload during a heavy task, like copying a big video file. Without DMA, the CPU is almost completely maxed out at 90%. But with DMA, look at that drop. it's barely breaking a sweat. It's free to keep the rest of your computer feeling fast and responsive. But of course, there's no such thing as a free lunch. Adding a DMA controller means you're adding extra hardware, and that adds cost and makes the whole system more complex. It can also create some tricky new problems, like something called cache coherence. That's basically making sure the CPU and the DMA don't have conflicting versions of the same data, kind of like two people editing different copies of the same document without telling each other. It can get messy. So, it all boils down to this one fundamental trade-off. On one side, you get this massive boost in performance, lightning-fast data transfers, and a CPU that's free to do its real job. But on the other side, it costs more and the hardware is more complex. For almost every modern computer, this trade-off is an absolute no-brainer. The performance gain is just too good to pass up. And that leaves us with a final thought to chew on. As our computers handle more and more data, we're talking 4K video, huge game assets, complex AI models, the role of these specialized assistants, like the DMA controller, just keeps getting bigger and bigger. It kind of makes you wonder, in the grand scheme of a modern computer, who's ultimately more important for keeping everything running smoothly? The powerful CEO or the hyper-efficient assistant that makes the CEO's job possible in the first place?